Alright, welcome back to day 39 of LeetCode grind. Solve or go home. 30 minutes solve or go home. Okay. Maximum points you can obtain from cards. Okay. There are several cards arranged in a row. Each card has an associated number of points. The points are given in an integer array card points. In one step you can take one card from the beginning or one from the end of the row. You have to take exactly k cards. Your score is the sum of the points given integer card points and k return maximum. Okay, so you're given points. One step you can take one from beginning or from the end. Okay. Alphaz, why you have double talk? Okay, I think I have an algo. So you're forced to take k, right? So I think what you want to do is have a min heap, and then you take the max of the top and the bottom, and then you check the next, and then you check the next max and bottom, and then if you could have gotten better, you pop it. Wait, actually no, that's the same word. Okay, so yeah, if you pop it, there's no way to know that the bottom was better. The bottom path was better. Maybe it's probably DP then.
What makes you say that?
Because you're looking for a max. It's usually DP.
I mean, I don't think that's always the case.
This is not always the case. It's mostly the case. Okay, wait. Let me think. So if I'm okay, at any given point, you want the max, but then the problem is you don't know if your current path had the max, because you could technically have taken 2 from the other side or 2 from this side. So you don't really know unless you have some way of tracking that.
Okay. So let's say you start with left side or right side, and you want to do all this stuff, right? Like, why is this kind of tricky?
Why is what kind of tricky?
Why is it tricky to track optimal solution? The optimal step at each point.
Because if you're only taking one from each side, you technically don't know if it's better to take like all from one side or all from other side. Because if you're only looking at two elements at a time, you don't really have access to elements in front of it.
Right. So basically, it's tricky because you can start at any point, and then you at that point you have basically 2 options. You're like taking from the left or taking from the right, relative to it, right?
Yeah.
And then if you keep doing this for a while, then at some point you're gonna have like way too many possibilities, right?
Yeah.
How to get there.
Sure.
So for things that are kind of like this, there's a kind of strategy where you like invert the problem, right?
Okay.
So instead of maximum that you can take, what is the equivalent problem?
The maximum you can take. The minimum you don't want to take.
Yeah. Okay. The minimum that you leave behind, right?
Sure.
Okay. So now is that an easier problem because?
Okay, I see. So kind of what you're doing is you have a min heap, and then you just pop out the min and try to take the next one or something?
It won't be a heap. So what do you know about any section that you don't take?
If you don't take from it, you can't take the preceding people after it.
Sure. But what do you know about every element that you didn't take?
Every element that you didn't take. What do you know? You don't know anything.
Okay, then let's look at the first example. So let's say you pick like the last three or the first three or whatever, right? Like, what can you say about what was left behind?
If you take the first three, you left 4, 5, 6, 1. If you take the last three, you left 1, 2, 3, 4. Oh, I see.
Okay.
So
And then if you took one from the left and two from the right, then two from the left, one from the right, etc. What can you tell about what was left behind?
you can tell the sum of the left behind.
Sure.
What can you tell?
Okay, let's analyze the first example. Okay.
Yeah.
Okay. So there are 4 possibilities.
Mm-hmm.
You take all from the right, in which case, what do you have left?
1, 2, 3, 4.
Sure. And let's say you take 2 from the right and 1 from the left.
2 from the right, 1 from the left. Is that what you said?
Yeah.
Okay, you got 2, 3, 4, 5 left.
Okay. So you take 1 from the right and 2 from the left.
You got 3, 4, 5, 6.
Okay. And what if you take 0 from the right and all from the left?
And then you got 4, 5, 6, 1.
Okay. And what is, I guess, common about all 4 of these things that are left behind?
Usually the middle is left behind.
No, that's not what I'm going for.
What is common about what's left behind?
What type of thing is left behind?
What type of thing? That doesn't make sense.
Okay.
Do you mean like the bigger numbers left behind?
No.
Because that you can't guarantee that. What type of number?
Okay, why do we not care to use a heap?
Why do what?
Why should we not use a heap?
You mean like any kind of heap?
Okay, why do you want to use a heap?
I don't know. That was just a thinking. I don't know if it's correct.
Are you familiar with the concept of a sliding window?
Yes. Did you say something? Hello?
Okay. You're familiar with the concept of a sliding window. What have you just created?
I guess. Yeah, you're just sliding. Your leftovers are the other part of the other elements that you didn't choose, I guess.
Right.
So typically sliding window, I think, is you drop one and you replace it with another element.
Sure. So if you are to take 3 elements, how many elements are going to be in the left behind window?
Length of array minus whatever you took.
Correct. So does that line up with what you observed?
Yeah, I mean that's always the case. You can't, if you take k, then you're left with length of array minus k always. There's no way to get.
So now you're starting from 0 index, and then you go to length of array minus k, right? That's your first window, and then basically at each step you're moving the window over, and then you just want to find the smallest window, which means you took the biggest things out, right?
Sure.
Okay, you have no idea how we got here.
No. Okay. So basically, you want to remove the big items because you want the array with the least numbers, because you want the minimum to leave behind. So basically you're sliding wait, that doesn't make sense though, because you want the max. So your sliding window, the opposite of the sliding window is what you want to return, but that's more than k. Right?
I don't understand what you're talking about.
So the question is to get the maximum sum. But if you're trying to minimize the sliding window, then isn't that the wrong approach?
So in the first example, if you take out 1, 2, 3, 4, then you are guaranteeing the maximum that you took, right? If you leave 1, 2, 3, 4 in the array.
Oh wait, so you're actually taking them out of the array?
No. What do you mean?
You said if you take them out.
No. If you leave 1, 2, 3, 4, then you're guaranteed to take the biggest 3 elements that are contiguous.
Sure. Okay. That's true. But I don't see how you're building that.
When you're building that.
Because you're doing a sliding window, right? But then your sliding window is, I'm not sure how to say it. It's weird how to build it.
Okay. If your array has 7 elements and you're taking 3, then what do you leave behind? How many do you leave behind?
4.
You're good. So now the whole point here is to find the 4 smallest contiguous elements to leave behind. And then that means if you took the smallest number, if you left behind the smallest number, that means you took the biggest number.
I see. But when you say contiguous, it can wrap around too, right? It doesn't have to be from one direction.
The thing you leave behind cannot wrap around.
Oh, it can't?
Well, think about it.
If you leave it behind, then you can't access the other people. Right. Okay, that makes sense. So it has to be either from the left or from the right.
So you start from the left, and then when you reach the right index, that's all the sliding windows you have, right?
Okay, yeah, so basically what you're looking at is you're trying to look for the group of 4 that's the smallest starting from the left index.
Right.
So you look at 1, 2, 3, 4, and then you have a sum of that, and then you check 2, 3, 4, 5, and then you check 3, 4, 5, 6, right? And then 4, 5, 6, 1. And then whatever is the least one, you want to return the sum of the array minus that.
Right.
I see. Okay, that makes sense.
I feel like you think it was kind of magic that we got to this point, because I tried to walk you through what happens if you take all 3 from the right, then 2 from the right, and 1 from the left, 1 from the right, 2 from the left, all 3 from the left, right? And so that did not, I guess, lead to this next step. So I still think that you're maybe feeling like this was like hacks or something.
Yeah, I don't see the jump from that to this for sure, but I do get why this works.
But anything that you do has to take at least one from the left or the right.
Yes, for sure. Yep.
Which means that anything that it contains can be at most that many things from the right, and then at most that many things from the left. So anything in that range where you swap things in from the left and the right will be covered, right? So on one extreme you'll have 3 things from the right. On the other extreme you'll have 3 things from the left, and then you kind of can move one over between the 2, and then you get a new array, right?
Yeah, if you move one over, yeah, then yeah. So, but basically, but because of the way the sliding window is, it has to be contiguous. So that's why,
Right.
yeah,
So this is how you think about it, right? Like basically, the amount you take from the left and the amount you take from the right is at least 0, right? So that means your window will not exceed the length of the array.
yes,
So if it happens to be 0, that means your window completely is up against that side of the array.
you're saying k.
There's one,
You're saying
two,
k equals 0.
right?
Are you saying k equals 0?
No, I'm saying if you took 0 from the right.
Oh, I see. Okay.
You take 0 from the right, that means your window starts at the right. Or ends at the right, I guess.
Ends at the right. What do you mean by ends at the right?
Your window is size 4, it starts somewhere and it ends somewhere.
Sure. Okay.
If you take 0 from the left, and it starts at 0, and it ends at length minus k.
Uh-huh.
If you take 0 from the right, then it starts at length minus k, and it ends at right. Right.
Minus k. Yes.
No. It starts at k and ends at the right.
Yeah, so if you're saying if you took nothing from the right side, then you start at index k and you go all the way to the end. And then if you took nothing from the left side, then you start from the length of the array minus k index.
No, you start at 0. If you take nothing from the left, that means you're starting from there.
No, if you took nothing from there.
Maybe it makes sense if you write this out. Like, we can talk about it, but I don't think you're visualizing it the way that it's useful.
Okay, what exactly do you mean by taking? When you say taking, you're talking about the traditional taking.
There's four possible outcomes to this problem with example 1.
Yeah, but when you're saying taking, you're talking about traditional taking. You're not talking about leaving behind, right?
Right.
Okay. So
Let's copy this array, copy it 5 times, and then for the first part, we won't change it. And then everything else afterwards, we will change. So I guess if we take it, we can put a dash between. We can put a dash on the number.
how do you put a dash on it? Like that?
Delete it and replace it with a dash.
Oh, okay. So yeah, if you took 3 from the right side, it looks like that.
Well, you should put that at the bottom. I think the ordering will tell you much better how to think about this.
What do you mean?
I guess, no, continue, and then move line 5 to line 8.
Okay.
These 4 are the only valid moves that you have
Yeah.
for this.
Mm-hmm.
Okay.
Yeah. This is basically the 4 sliding scenarios that you have.
Right. So, because you're taking some amounts that's even if it's 0, right?
Uh-huh.
What you leave behind is a contiguous window, a contiguous subarray,
Yes.
right?
Mm-hmm.
Which starts at, I guess, either 0 or k, depending on which side you want to start looking at.
Okay.
And then it ends at n minus k, or I guess length minus 1, right?
Mm-hmm.
So now you don't have to worry about what was taken.
You're just worrying about what is you didn't take, and then you reverse engineer the sum of the stuff you took.
Right.
Okay. Yeah, because these are all the scenarios of which, all possible scenarios of what you could have taken. Whatever remains is what you didn't take, and you just want the sum of the total array minus what is you left behind. That means what you took. So because of that, this is why the sliding works, because
so for any array, you can greedily take from one side or the other side, and those end up being your endpoints. And then to get to something in between, you just shuffle one over.
yes.
Which is equivalent to moving the sliding window over one space.
Okay. Because every time you're sliding a window, it just indicates that you're leaving a left taken on that side, and you're taking something from the other side.
Right.
Okay, that makes sense.
Okay. Well, I don't know. I guess, we'll go with the algorithm in terms of the inverse of the problem is the hardest part, I think. And then coding it should be relatively straightforward.
Yeah, the code is pretty simple for this. The only thing is this is probably like a maybe optimal solution, but like, is there a way to do it without doing the inverse way? Like, if you had, like, do you have to think of the inverse way to handle this? Otherwise,
no, you don't have to, because you know that it's k things, right?
Mm-hmm.
So you can do a sliding window of what was taken instead of what was left behind.
Yeah, that's what I. Yeah, that.
I guess it's harder.
That
will be tricky.
That's harder to code, but it's simpler to think about. Like if I were to do it, I would probably think of that up instead of this, because this is much trickier to like come up to.
You know you'll have a sliding window of size k, and then you're gonna pop from the right, and then take the left element, etc. Right? And it's the same thing. You can code that one as well, but it's the same thing.
So
you start at one end, and then you have to shift through and check everything. If you swap one in.
Yeah, basically you need 2 pointers, right? And then it's like, if I took this, I have to pop this, and then I just move it over and grab the other one. The problem is, it's probably much more iterations, isn't it?
No, the same number of iterations.
Is it?
Because you don't start at the right index or the left index. You start at maximum of right or maximum of left. And then you just slide over until you have 0 of that. Which is equivalent to the left behind case.
Wait. Maximum of right and maximum of left, you said?
So you just pick all of, you assume that you took all left first. Right?
Okay.
And then you do sliding window to remove one and then shove it over to the right, etc. Right?
Oh, so you assume you took all left, and then you just slide until you get the best number.
Yeah, at some point you'll get the best number.
Oh, does that work?
It's the same thing. If leaving stuff behind works, then that's equivalent to taking stuff and then putting it back.
Okay, so if you started with 1, 2, 3, right, and then you check the sum of 2, 3, 4 is, oh, that's bigger, so I'm gonna leave 1 behind. Then
you don't check 2, 3. No, you cannot check 2, 3. You have to check 2, 1, 6 or 2, 1, 1. Sorry.
Oh, so yeah, so you can't do it like this. Then. Oh yeah, right. No. I mean, you can't. It's not this way because you can't do 2, 3, 4 because if you didn't take 1, you don't have access to 2, 3, 4. So your sliding logic is much more complicated. So basically, if it's 1, 2, 3, you drop 3 and you take 1 and you check that. It's like, oh, never mind, that's not good. So then you drop.
No. What do you mean? No,
well, you have to actually. No, because if you took all left, there's nowhere to go. You have to drop 3. So you drop 3 and then you take 1, but then the max is still lower than your previous max. So you don't. It doesn't update. Yeah. So then you keep going. Then you drop 2 and you pick up 6, and then you drop 1, you pick up 5, and then you'll see that 5, 6, 1 is the max, and then that's it. Oh, okay. Yeah, that's actually not too hard to code either, I think. And that was probably way easier to think about than this one. But I get this. I get
They're
this.
completely equivalent. So
Yeah, I mean, it is. It's just like the thinking to jump to this inverse is much harder than that one. But I think they're both.
okay, then do what you're comfortable with.
No. I mean, I understand it now, so I can just code this one. But I can also code the other one too. The other one doesn't seem too hard to code, but it's probably a bit trickier than this one. But only slightly, I think. So I think, okay, first off, I need a total R equals sum of lists of card points. So I have the total sum, and then I want to do actually, is this easier to code than the other one? The other one seems easier to code. Okay, wait. Okay, so basically I need to do okay, it'll be like I'm basically building subarrays and summing them. But the problem is, okay, what I want is the minimum of the subarrays. So anytime I update the min. The subarrays, okay, the subarray length is equals to get so then it should be for it's like while wait, no. If I do that, every time I shift end over, it's gonna be a longer array. So I need to start also. So it should be 0 to end, and then I sum that. increment start and end. And then just return total R minus min sum. That should be good. Oh no, this is hard-coded 0. It should be start.
This might time out.
Why would this time out?
If you're summing every time. The thing with the window is that you could just
keep a total and just
in memory and then pop from the left and push to the right.
I see. Okay, that's fine. So that's the case. Alright, then if that's the case, we just want to start with, okay, sub R equals current points. That. I still need to track the end. Okay, so every time I'm looping through, I pop the left value, I'll insert the right value. Okay, let's make this a DQ first. Wait, I need a DQ. Actually, wait, do I even need the array? I just keep track of the sum. Okay, so wait. Cur sum equals sum equals sum of card points from 0 to sub RLN. So I have that, and then while, wait, actually no, if I just have the sum, I don't know what I'm popping out, so I do need the array. Okay, but I also need the current sum. Okay, so I need to loop through this. Okay, I actually know how many times I have to loop it. It's basically each slide window is move over one index. So if I'm starting from the beginning, then I just have, it's just length minus k. So it's for I in range sub rlen. That's how many times I have to loop. Sub array length is 4. Wait, is that true? Length of card points is 7, minus k is 4, yeah. But do I want 0 to 4? Wait, no, I do. Hold up. Yeah. Okay, so 0 to sub r line. Okay, so actually this should be range in k actually. Okay, that means for each k I pop one. Okay, that should be fine. DQ this. Sub r dot pop left. And then I do cursor is equals. But actually, I don't have to do that afterwards. Okay. So I pop it, and then I say, what is card points? Okay, so it should be k plus I. If I start from index k, that is so 3 here. This would be 0, 1, 2, 3. Yeah, so I start here. I want this index. Yeah, so I pop that index and I'm adding this index. That's fine. K plus I. And then if it only goes up to range k, which is 3, what's k plus 3? K plus 3 is the last index, right? K is 3. 3 plus 3. Actually, no. If it's for I in range k, it's gonna be k plus 0 to start, and then we don't want that because what k plus 0 is, what is it? Yeah, that's not doing anything for us. So we should start from 1 to k. But then, do we k plus 1 this? What's k plus 1 equals 7? Index 0, 1, 2, 3, 4, 5, 6. That's out of bounds. Okay, that is out of bounds. So do I not need to do it to k plus 1? If I do 1, for I in range of 1 to k, 1 to 3, it just does 1 and 2, right? Does that just do 1 and 2, or is that 1, 2, and 3? Let's see. There's only 1 and 2, okay. So I do need plus 1. But then does that break this? It's k plus 1. K is 3. 3 plus 1, 3 plus 2, and then 3 plus 3. Oh wait, why am I? Yeah, 3 plus 3 is fine. 3 plus 3, yeah, that's 6. Okay, this is fine. Okay, so I pop it, and then the add is this one. So then per sum equals per sum minus pop plus add. And then I do sub r dot append card points. No, it's just add, right? Yeah. Okay. So I pop the left. I get the element I need to add to it. Update my current sum. I add it to the back to the array, and then I update min. So min of min sum and cur sum. That should be good. Except it's not good. What's wrong here?
Your min is not defined for the first
Oh, wait. Oh, because I start at 1, 2, 4. Oh, that was supposed to be the min, yeah. It's because I started as float. Oh, it's because I already did this. So min should just equal cur sum at this point. That should do it.
Why do you need a cur sum and a min sum? Should this be equal?
What you say?
Oh, I see. Okay, never mind. Yeah. You're right.
Okay. I'm gonna do this one. I think this is fine though. I think it's actually much simpler to code the. Oh wait, this is broken. Shit.
Then code it the other way. Your answer's wrong, by the way.
Yeah, I know. I just realized. I mean, I didn't realize, but it's returning wrong. What's wrong with it? This algo seems correct.
I think your range is measured off.
My range? Or do you mean my sub R? Oh yeah, it's too long. Length of card points minus k. Why is it 5 of them? What is? No, that's too many, right? Oh wait, no, that's correct. There's 3 left behind. Yeah. Wait, then that's not wrong. Then what is?
I think your other range is
wrong. My for I in range I to k plus 1. Wait, why is that wrong?
You print sub R at each step to where it stops.
Okay. Yeah, so it's 79 to 1, that's correct. And then it does the 80 to 1. Wait, why did it didn't add the 200? It added a 1 instead. What happened there? So at the first step it popped a 1 and then it appended a 1, which looks correct. Then it popped to 79 and it's supposed to add the 200, but it added a 1. That's weird. Card points plus k plus I. Why is add wrong here? It has 4, 5, and 6. So index 5. What's index 5? 0, 1, 2, 3, 4, 5. Oh, okay, so it looks like it started wrong. Okay, wait, so if I started with this 0, 1, 2, 3, 4. Oh, k plus I is only 4. That's wrong. Why is k plus I 4? Oh, wait, so it's not k plus I. Wait, hold up. K plus I. Okay, so I is okay from 1 to k plus. Oh, this is wrong. It shouldn't be k plus 1. Wait, no, wait. If I start at 1, and then I'm doing card points of k plus I. So k. Oh, no, it shouldn't be k. It should be the remainder index. Sub r11 is my starting index. Yeah. Is that out of bounds though? Sub rlen plus k should not be out of bounds. Alright, 1, 2. So it's 3. So if I start at sub rlen, which is 5, right? 0, 1, 2, 3, 4, 5. I start here. Okay. 0, 1, 2, 3, 4, 5. Technically, I'm supposed to start at -1. That should be fine, I think. Yeah, that looks good. So then I popped it. Yeah, pop in the 200, and then I pop in the 1. Yeah, that looks fine. Put the first case back in to make sure that one didn't break. Yeah, looks good. Okay. This one. Oof. Okay. So DQ is empty. Why is the DQ empty? 1, 0, 1, 2, 3, 4, 5, 6. Wait, what? Is this already less than this? You have to take. Okay. Oh, that's why. So my DQ of 0 to sub r length. So it was 6 minus k, which is -1. I'm trying to build a DQ of 0 to -1, which does not exist. So that's an edge case. Let me see. Just make sure I think it's empty. Yeah, okay, so if I think that should be fine. Actually, no, I don't even need to do this. Okay, it's if k is Or is it still popping? Oh no, it's the opposite direction. That's fine. Okay, that was good. Alright, I think I'm gonna code the other way. I think that's easier than this one. What happened? What'd you say?
It's gonna be the same.
Are you sure it's the same? It looks, I think it's much simpler. Alright, delete this. I'm gonna keep this though, because that's, actually no, I don't need that, I think. So, okay, so I assume that I take the total R. So I assume that it is actually no, I need that case. Okay. Okay, then else I build the starting array. Q of 0. Okay. Zero to K will get me. Yeah, let me print that just to make sure. I think it is correct. I think you have 1. That's not correct. Oh, no, that is correct. This is a 1 case. I need the other one. This one, 3. Yep, that was good. Okay. So I have a DQ. And then, okay, so I have the length of this, and then I want to slide the rest of the time. So it's for I in range of len card points minus K. Okay, but I want to start at K. Wait, no. I'm popping from the end of my array and I slide in the other side. Actually, you're right. This is way trickier code, I think. Yeah, where is it? How's it the same? Actually, no. I think you're right. It is the same.
I think I agree the same.
Yeah, this is literally what I just did before. Right? No, it's slightly different.
Okay, sure. It's slightly different.
Wait, is it slightly or is it way different? Cause wait, is it? Oh my god, what the hell? Okay, wait. So basically, I have the starting array of 1, 2, 3. I want to pop 3, and I want to slide in 1.
Well, if you don't want to do this, you just do 2 arrays, right? Left array and right array. And then just add shit.
That makes sense. Okay. Okay, the problem. Okay, so how many times do I have to loop for this? I need to loop for length card points minus k, which is what, 7 minus 3, 4 times. I think 4 times is correct. Yeah, 4 times. Okay, so while this happens, left are okay, I need a sum. Left sum equals sum. Yeah, I don't need that. Just one sum. Okay. So, okay, doing this, I do. Oh, right. I'm popping right. I'm not popping left. Okay, sure. That's fine. Wait. I'm popping right for this one. Oh, yeah, the other side I don't need to pop at all. Yeah, okay. So ret is the max between rets and ret minus LA plus card points I. Wait, no. Is it I? No, it's not I. It's from the right side. Just -1. I'm trying to access from the right side of the array. So index -1 plus I should get me the reverse way, right?
It's element, but red shouldn't change. Wait.
No,
To your current sum and your minimum sum. Like,
I don't need that anymore, right? Because the only reason I needed that was because I'm tracking the minimums, but here I'm tracking the maximums, so I can just straight up.
okay, you're tracking the maximum. You still need what your current number is. You don't want to calculate the sum every time.
No, I do calculate it. Oh wait, I don't store it first. Okay, fine. Okay, fine.
What's -1 plus I?
You're doing it from backwards, right? That's how you.
No, that's not.
That's not? What do you mean?
That becomes I -1.
Is it? No, because okay, so if you start at 0, right? -1 plus 0 is -1, right? Oh, I see. Okay, so it should be minus I. Yeah, 1,
Where
6.
do you update the right? Oh,
What happened?
where do you update the right array?
I don't yet. I was just printing this to see if this is popping it correctly. Okay, so this one would be current sum minus element plus, yeah, plus you add 1, you add 6, you add 5. That's good, okay. Right array is empty. So I should. Okay, wait. Oh wait, no, this, I don't need to do this. I can just do while left R. No, I don't even need a right R. Why do I need a right array? You don't need it. And then I just decrement index. I think that should be fine. Yeah, that looks fine. Yeah, I think that's good. Yeah, this is, I think this is a bit simpler than the other one.
Sure. All of those things? Oh, an hour.
Yeah.
Okay.
Well,
Nice.
it was 40 something minutes for the other implementation. This one was way shorter. But yeah. Alright, I guess that's it. Thanks. Unless you got other stuff to say.
I think your organization and in terms of what you're doing is a lot.
Uh-huh.
This is not a, should not have been a 1 hour problem.
Well, it wasn't 1 hour, right? But yeah.
Yeah. Okay.
Alright, thanks. Bye.